Hello friends, welcome to Deriving. We will consider an interesting problem on coordinate geometry. What is the problem? Problem is, let AS be a square of a unit area. Consider any quadrilateral which has one vertex on each side of S. If ABCD denote the lengths of the sides of the quadrilateral, prove that a square plus b square plus c square plus d square is greater than equal to 2 but less than equal to 4. So this is the problem. So consider a square ABCD whose area is unity. That means side length of the square is one unit, and consider another quadrilateral PQRS whose vertices are lying on the sides of the square, which has one vertex on each side of S. So PQRS is that quadrilateral which has one vertex on each side of S. Alright. Now if A, B, C, D denote the lengths of the sides of the quadrilateral, so PQ is A, QR is B, SR is C and SP is D, then you have to show that A square plus B square plus C square plus D square is greater than equal to 2 but less than equal to 4. Now in such type of problems, geometrical problems, we generally consider a coordinate system of my choice and convenience. So here I choose a coordinate system like this. This is x-axis. Say, let me choose different color. Let us choose a coordinate system like this. This is x-axis, and consider a coordinate system whose y-axis is like this, y-axis. This is the point A actually. Now, with respect to this coordinate system is such that the x-axis is along BC, y-axis is along DA, and D is origin. So with respect to this coordinate system, I can write the coordinate of D as 0, 0, coordinate of C as 1, 0, coordinate of B as 1, 1, and coordinate of A as 0, 1. Obviously. And since P, Q, R is they are lying on the sides of the square S, so I can write the coordinate of R as x1, 0. Since R is lying on x-axis, therefore its y coordinate will be always 0. And x1 is the x coordinate, and x1 is actually greater than equal to 0 but less than equal to 1. Similarly, Q's coordinate let me write as 1, y2. y2. y2 is similarly y2 is greater than equal to 0 but less than equal to 1. Similarly, P's coordinate, let me write, it is y coordinate will be y, but x coordinate is x3, and x3 is such that x3 is greater than equal to 0 but less than equal to 1. Alright, and x3, and coordinate of S will be 0, y4. Such y4 is such that it is So I can write the coordinates of R, Q, P, S as x1 0, 1 y2, x3 1 and 0 y4. Up to this, I think it is clear to you. Now you see the triangles DRS, triangle RCQ, triangle PBQ and triangle APS. All these triangles are right angle triangles because these angles are 90 degree. Therefore, I can readily apply Pythagoras theorem in case of all the triangles. So, from the basic coordinates which are provided, drawn on this diagram, I can write a square. A square is actually PQ square is BQ square plus PB square. But PB is how much? PB is, you see, PB is 1 minus x3. So it is 1 minus x3 whole square plus BQ is how much? BQ is 1 minus y2. So 1 minus y2 whole square. It is straightforward because PQ square is PB square plus BQ square. So PQ is A. So A square is 1 minus x3 whole square plus 1 minus y2 whole square, and if I expand it becomes 2 minus x3 square plus x2 square, 2 plus x3 square plus y2 square plus minus 2 x3 plus y2. I think it is clear. 1 plus 1, there will be one x3 square, there will be one y2 square, so they are taken together, and then minus 2x3 minus 2y2. So I have written like this. B square. B square is how much? B square is 1 minus x1 whole square plus y2 square. So it is 1 plus x1 square plus y2 square, x1 square plus y2 square minus 2x1. 2x1. Similarly, c square I can write c square is equal to x1 square plus y4 square, x1 square plus y4 square, and d square similarly I can write using Pythagoras theorem. D square is 1 minus y4 whole square plus x3 square. So it is 1 plus x3 square plus y4 square minus 2y4. Alright, so I can write a square plus b square plus c square plus d square is equal to 2 plus 1 that is 4 plus, here there is one x3 square, here there is one x3 square, here there is one y2 square, here there is one y2 square, here there is one x1 square, here there is one x1 square, and here there is one y4 square, here there is one y4 square. So I get 2 times x1 square plus, this is one x1 square, this is one x1 square. So 2x1 square plus 2y2 square, because here one y2 square, here one y2 square. Then x3 square, you see there is one x3 square and there is one x3 square. So plus x3 square 2x3 square basically. Then y4 square, there is one y4 square and there is another y4 square. So plus y4 square. Then minus, see, 2x3 minus 2x3 minus 2y2 minus 2x1 minus 2y4. So I get 2 times x1 plus y2 plus x3 plus y4 minus 2y4 minus 2x1 minus 2x3 minus 2y2. So this is the expression for a square plus b square plus c square plus d square. Call this as L. L is a square plus b square plus c square plus d square. This quantity L, we have to work on this quantity L. Now here I can write 4 plus 2, see, I write x1 square minus x1 plus y2 square minus y2 plus x3 square minus x3 plus y4 square minus y4. Bracket closed. I can, from this I can write 4 plus 2 x1 minus half whole square. So first term is x1 square minus 2x1 into half, that is x1 negative x1 plus 1/4. So I make minus 1/4 plus y2 minus half whole square minus 1/4 plus x3 minus half whole square minus 1/4 plus y4 minus half whole square minus 1/4. You should be very careful about calculations. So it is minus 1/4, here there is another minus 1/4, here another minus 1/4, here another minus 1/4. So I get minus 2. So ultimately I am left with 2 plus 2 x1 minus half whole square plus y2 minus half whole square plus x3 minus half whole square plus y4 minus half whole square. Is it okay? Now let me remove this thing. So let me remove this part of this problem. So what I do, here you see, I know that x1 is, sorry, x1 is greater than 0 but less than equal to 1. Okay. So x1 is greater than equal to 0 but less than equal to 1. So from this I can write x1 minus half is greater than equal to minus half but less than equal to plus half. So x1 minus half whole square is greater than equal to 0 but less than equal to 1/4. So from this logic x1, we started with this logic, x1 is greater than equal to 0 but less than equal to 1. So minus half is less than equal to x1 minus half, which is less than equal to half. So x1 minus half whole square, which is a positive quantity, is greater than equal to 0 but less than equal to 1 by 4. And therefore, similar manner I can show that y2 minus half whole square is also greater than equal to 0 but less than equal to 1/4. Similarly, x3 minus half whole square is greater than equal to 0 but less than equal to 1/4. And similarly, y4 minus half whole square is greater than equal to 0 but less than equal to 1/4. So these quantities within the bracket, these quantities, their minimum values are 0. So when they have their minimum values, L minimum becomes 2 plus 2 into 0 plus 0 plus 0 plus 0. Because I have 4 square terms inside the square bracket. Minimum value of each square term is 0. Therefore, L, which is actually a square plus b square plus c square plus d square, its minimum value will be when these squares are individually 0. So, minimum value of L is 2. And maximum value, when it will occur? When the squares have their maximum values. And the maximum values I have shown here. This is x1 minus half whole square is always less than equal to 1/4. Similarly, this is always less than equal to 1/4. This is always less than equal to 1/4. This is always less than equal to 1/4. This is also always less than equal to 1/4. So L max occurs when this is 2 plus 2 into these values are maximum. So it is 2 plus 2, 4. So L minimum is 2 and L maximum is 4. Therefore, L lies in the range 2 to 4. So L is how much? L is actually this thing, a square plus b square plus c square plus d square. So a square plus b square plus c square plus d square is so this is the relation that we wanted to prove. I think the steps are clear. You choose a coordinate system of your convenience. From that you find the coordinates, and these coordinates x1, y2, x3, y4, they obey these conditions. Then using Pythagoras theorem, calculate the value of a square plus b square plus c square plus d square, and you find that this expression can be expressed like this. And these quantities, these are all square terms, and these quantities can never be 0. It can never be negative. Their minimum value could be only 0. These square terms can never be negative. So minimum value occurs when these square terms individually they are 0, and their maximum values are, we have already found, 1/4 individually. So L mean is 2 plus 2 into 0 plus 0 plus 0 plus 0, that is 2, and L max is 2 plus 2 when individually the terms are maximum and they are 1/4. So L max is 2 plus 2, 1/4 plus 1/4 plus 1/4 plus 1/4, that is 4. So L lies in the range 2 to 4. Okay, so this is the required relation. So simple geometrical techniques you have applied and solved this problem. So similar type of problems you can handle in exams, in your competitive exams, and you can crack your exams with these skills. I think this has been useful to you. Thank you very much for your listening. Thank you very much.